Okay, so we're gonna look at this very brief class hierarchy, and where we are is we'd partly implemented the employee class. So where you are in this is starting from a design such as this, and I find these UML class diagrams to be very useful in that they describe the structure, at least the major parts of the structure of a particular class. They don't tell you how they're going to be implemented, and so this isn't necessarily complete, but it gives you a framework to start, rather than just sort of sitting and trying to type. In other words, it gives you a kind of a goal, as it were. And as we all know, if you don't know where you're going, you can probably, I forget how the rest of it goes. So, all right, so we had implemented the employee. We'd had this abstract superclass that had the name. Okay, so what are we looking for? We're looking for the name instance variable, a double that's a salary instance variable, and a local date that's the hire date. So far, we have the name from the superclass, but we added the salary, and we had a getter for all that. Now, for those of you who've had a little more experience, you've noticed that I haven't considered the fact that you could enter a negative value here, and there's nothing to prevent that. It would be nice if a language had a type that was say a positive double, but it doesn't. It just has a plain old double. So there's nothing to prevent giving somebody a negative salary, which means every payday I've got to pay the company. Sometimes it seems that way, but and we're going to address that later when we talk about exceptions. So, but for right now, we're going to pretend that that's not the case. Okay, we're going to assume that whoever is using this class is going to give us a valid value, and that assumption is a terrible one, because users, in this case, who would be a user of this class? Somebody who's writing a program that would instantiate this particular class. Okay, but now I want to take just a little bit of a detour, but I think this is an important one for a number of reasons. One is this, remember we had this local date thing? Where are we here? Okay, so this hire date is going to be one of these local date jobs. And this is going to represent the date at which this particular employee was hired. In the person the person superclass could be not employed, say self-employed or whatever, so we don't worry about that. But if you're an employee, the presumption is that you're being employed. Okay, a couple things. Now, notice I typed in local date, and I get a red squiggly. So when you type in the name of a class, and you get, and NetBeans is complaining, and the complaint is it cannot find the symbol. If you're, why have I typed this in? Well, because I'm pretty sure that this class actually exists. In this case, it's a class in Java, but it could be a class that I've written that's in another package. Okay, so the way that a Java class finds things is that if it's in the same package, remember we talk about named packages, so anything that's in the named package, I can simply refer to by its unqualified name, and the unqualified name is just the name of the class. So in this case, for example, employee is the unqualified name of this class. Its package is CS2173, so the fully qualified name is CS2173.employee. That's really that is it's called the fully qualified name because it has the package and the name of the class. And in the Java, that's the name that the Java virtual machine sees. Like under the hood, Java virtual machine does not see employee. It sees CS2173.employee. That's the full name that Java sees. But that's a lot of typing. So for a class in the package, I just have to use the name. And if I want to refer to another class in the package, like any one of these, I can simply refer to them by name without including the package, because I've kind of put that context here. Okay, but here's a class, and because it can't find it, there are only three possibilities. Okay, first it's in maybe a few more. The first and most likely is that I fat fingered it. I've typed it, I've mistyped it, and it's because Java's case sensitive. I may have typed the wrong case, and that's something that can happen. Okay, second possibility is that the class simply doesn't exist anywhere. In a way, that's kind of related to the first one. The third possibility is it's in a package that I've written that's different from this one. And the last possibility is that it's a Java class that exists somewhere and not in java.lang. If it's in java.lang, then I can automatically use it in an unqualified way. But every other package, I can't. Now, how do I find out about this? Well, if you look very closely, you can see that there's both a red alarm and a little light bulb behind the red. And if I click on that, and unfortunately I can't make the pop-up any bigger, it gives me three options. It says, okay, you've defined this thing. The first option is add an import for java.time.localDate. So again, java.time.localDate is the fully qualified name of this class. And you can see that it's in the package java.time. Now, the other possibility is to say I can create you say, well, if I don't want to use that one, maybe I can create my own. And if I create a class local date in this package CS2173, then the name of that class would be CS2173.localDate. So even though the class has the same name as one that already exists, there is no confusion because the real name of that class is CS2173.localDate, and that's different from java.time.localDate. So that's the power of these named packages, and that's why you should always put your classes in a named package because it makes it easier to do these things. In other words, supposing I didn't like the Java local date and I wanted to kind of roll my own, I can absolutely do that. I can define my new class. Now, I don't want to do that because the one in Java is actually quite nice. And when it says add import, it literally adds this statement, import java.time.localDate. And as I've said previously, it's a very badly named keyword because it's not actually importing anything. It's just saying that because I've identified this, because of this statement, I can now use local date in an unqualified way. So that's all it does. It actually doesn't import anything. And that's different than other languages that have like include or import like types of things that literally import what's in the other thing. This doesn't import anything. So that's why it's very badly named. And this local date class, and there's a similar one called local date time, are actually quite nice. And so part of what I'm going to talk about today are just things that you can do with that. Now it turns out, fortunately, that local date is a final class. It's like string. Okay, remember, with string, once I instantiate a string, I can't modify that instance of a string. It's immutable. I can create new strings by concatenating them. And likewise here, a local date, once I instantiate it, is immutable. I can't change that instance of it, but I can create other local dates from that in kind of a nice way. And if you want to kind of see that what's going on, you can actually look at the source code by I right-clicked on this. I said navigate, go to source, and okay, now look, public final class local date. So whenever you define, remember the keyword final says, that's it. So it can be applied to to variables, instance variables, class variables, and it can be applied to methods. So if you apply it to a method, it means you can't override that method. In this case, because it's applied to the class, public final local date, it means that when you instantiate it, you can't, it means you can't subclass it. But it turns out it's actually also immutable. So and it's got a lot of stuff in it. The thing with dates, and actually it took Java several iterations to get this right, and you see, dates are complex because, well, for example, this is 2020, and 2020 is a leap year, as you all know. So what does that mean? It means that February has one extra day in it. And how do you know a year is a leap year? What?
Did you look it up on Google?
Oh, yeah.
Divisible by 20 and by 200 or something?
Yeah, the first cut is if it's divisible by 4, every 4 years there's a leap year, except when it's also divisible by 100. So in 2000 would be a leap year by the divide by 4, but it was not a leap year because it was also divisible by 100. And the reason for that is because it's the astronomy and the things are kind of off. And in addition to that, there are leap seconds, which like every now and then you're off by a second. So like they kind of jump a second ahead or something like that. It doesn't affect us as much as a friend of mine's birthday is on February 29th. So he's been around for about 40 years, but he's only 10 years old. So anyway, so it's a complicated thing, and it actually took Java, they actually had the math figured out, but it took them a while to kind of get the class working right. And in a way, I take heart in that, in the sense that the people who developed Java were really, really smart and really good programmers, much better than I will ever be. And if they struggled with it, then that means if I struggle with something, then it's not such a big deal. But anyway, with local date and local date time, I think they were finally able to nail it. Their previous version, and the book talks a little bit about the date class, which was their first attempt at it. And you'll notice that they have, in the date class, there are a lot of methods that are deprecated. So you can, one of the things you can do with a method is identified as being deprecated. What does that mean? That means that we kind of blew it on this one, but because it's been out there and people have been using it, we can't just take it away. But what we're going to do is we're going to mark it as being deprecated, which means every time you compile with that, especially with a certain switch, it'll say, well, you're using a deprecated method. Watch out, because when you identify a method as being deprecated, in the next version it may go away. Okay, so here's this higher date. Again, because it's immutable. Once it's like if you were hired on thus and such a day, then that's when you were hired, and we're not going to say, well, what if they quit and then get we're not going to worry about that just yet. Okay, so in this case, we don't want a setter, because what are the implications of setters and getters? The question is, who can do what? The principle of encapsulation says that the only methods that can directly access the instance variables are the methods in the class. Those are the only ones who are allowed. So somebody who's instantiating one of these, somebody who's using one of these, they are absolutely not allowed to directly manipulate any of these instance variables. But if you can't manipulate them at all, then your program can't really do very much. So what can you do with these is something that, as a designer of a class, you decide. Say, what if somebody has a reference to this employee, what is it that they're allowed to do? Or if they're going to instantiate one of these, what is it they're allowed to do? Well, one of the things so for the hire date, I don't want anybody with a reference to be able to set this value, because if I was hired on thus and such a date, and when I was hired here would give away my age, so I'm not going to tell you that. But it was many years ago, maybe before some of you were born. But that's so I don't want anybody to be able to set that, and if that's the case, then I don't want to give a setter. But I want, if you have a reference to this, should you be able to see it? Well, again, this is putting aside the PII issues. If somebody has a reference to this, they should be able to, I'm going to let them see that. So if that's the case, then I define a getter. And the way a getter is get the variable name with the first letter capitalized, and then it returns the one of the same type. Now that's not, when you have something like NetBeans, or almost every ID has this kind of feature, you don't want to be actually typing that in. You want to, in this case, use this refactor, encapsulate fields, and now it's giving me the option of a getter and a setter, and I'm just going to choose the getter. And I want to put it the last method, and I want to keep the fields visibility private, but the accessors visibility public. This is saying, I'm saying, if you have a reference to this employee, then you can get their hire date. Okay, but now I don't have a mechanism to actually sort of set that. So what I need to do is kind of put that in the constructor. Oh, no. So now in this case, okay, remember for salary, because I had a setter for salary, I could use that setter. But here, I don't have a setter, so I have to do it this way. There's no other choice. And now, okay, now this constructor doesn't make a whole lot of sense. However, I can give it, if I'm saying, okay, I want to instantiate an employee, but I'm not going to tell you when the hire date is, let's assume that hire date is today. Is that a reasonable assumption? If I'm not going to, when else would it be? So, and one of the, okay, so what did I do? I gave it local date.now, and it stopped complaining. Okay, so what is now? Not in the philosophical sense, but what is this method now? Well, it's a method. I gave that away. What type? What type of method is it? Is it an instance? There are only two possibilities. It's either an instance method or a class method. Correct. Why is it a class method? Because it's referenced with a class. In other words, I didn't give it an instance and referred to it. I gave it the class name and referred to it, and that means it can only be a class variable. And that's a very, again, one of the convenient things that they have is they say, okay, I don't need to instead. In fact, this will instantiate a local date who it happens to be today. Now is a little bit misleading because now is the 24-hour period for this particular day. Okay, so now now I didn't have the, let's see, did I have a, oh, I never really, okay, so let's instantiate this and see what is going on here. So let's create a class, and notice I'm creating in a separate class, a separate package. In general, there are two types of classes that you will have in an application. One are you have your component classes. So employee is like a component class. These are things I'm going to instantiate, and then I'm going to have at least one main method, and then a lot of times I'll have some helper classes. But okay, so here let's okay, now the NetBeans was kind of doing this for me, but I wanted to illustrate this again. Remember, back when I typed local date, it complained, and now it's giving me the same complaint. It says it can't find the symbol. And this may be a little confusing because you say, well, look, employee is in the CS2173 package. Run looks like a sub package. And so why can't it see what's in the CS2173? And the answer is maybe by some rights it should, but it was an arbitrary decision that the package names, regardless of how they're made up, are unique and have no other relationship to each other except on the file system. In other words, CS2173.run is just a completely separate package than CS2173. And they, from the program point of view, they have no relationship to each other. It's just a separate package. And so because it's a separate package, I can't use the unqualified name like this. Now the thing is that I can always use the fully qualified name. I can always do this. Okay, so notice it's totally happy. Why? Because I've given it the no kidding actual name of the class, and the no kidding actual name of the class is the package and the name of the class. And if I give it that fully qualified name, then I can do that with literally everything. That is, back here, instead of trying to import this, just everywhere I have local data, I just have to refer to it with this whole thing. But that's a lot of typing. For now, I'll leave it like this, but if I were to do another one, okay, so it's important to kind of understand that. All right, so now I will say, okay, let's see what this looks like. And what it looks like is basically, okay, now where did it get that? Okay, so it gave me the fully qualified name of the class, this gobbledygoo, and then the name. So where did that come from? That came from the abstract superclass, or okay, I didn't make it abstract, but that came from the superclasses toString. Okay, and that's still it's not very useful. So what is it that I really kind of want in a toString for this, I want something that's a little more descriptive. So let's and then the other thing is that, remember, how does the virtual, before I add another toString, how does the virtual machine find a method? Okay, what was it trying to do? When I go to print it, it says println looks for the toString. And it can always find the toString because toString is defined an object, even though it can be overridden. So it says, I want the toString of John. What is John? John is an employee. And so let's look at employee. Well, now here we haven't done it yet here. Now, no, just as another aside, when we are using Git for things, NetBeans kind of color codes stuff. Remember, green stands for new, and actually, one of the nice things, if I click on this, I can actually kind of undo what I did. So right now, employee. Oops. What are you complaining about? Oops, I was a little too aggressive. Okay, so employee has no toString, so it looks to the superclass. And the superclass, okay, there's a toString, and what did it do? It first called the super, and the super of person was object, so that's where that first gobbledygook came from. And then it added the name. Okay, so remember, so how the virtual machine finds a method, it starts at the actual instance and then starts marching up until it actually finds it, and it will always find it because of the compiler. Now, just sort of as a second little thing, because an employee is a person, I can define the variable to be a person, and it will still, okay, now this is actually, it's kind of ambiguous now, because you say, well, why did it call the toString of person? It called the toString of person because it found it by marching up through employee, not through person. All right, and here's how I can prove that to you. By let's override toString in toString. And again, it's got to be exactly the same. And what I'm going to return is remember, we talked about printf at some point, where you can kind of format things, and we've used that a little bit. Well, it turns out the string class also has a format method that does exactly the same thing. So I can format, and what I want to do is I'm going to give the name. I want to give the salary. Now I'm going to give the salary. Remember, a double can have as many decimal points as you want, and so if I have a salary of, let's say, 80,000 and 0.23578, last I checked, we can't get a fraction of a cent, at least in this country. So what we can do is, is that when I print the salary, I'm going to give it only 2 decimal places, because that's the most I can do on this, and then I'm going to print the hiring date. So all right, now so in this case I'm using the getter. For the name, I have to. For the salary and the hire date, I don't. Which one should you do? If you have a choice, it doesn't really matter. And I actually, a while back, I did some tests on this. And you say, well, if you look at this, you say, well, in In principle, if I use the getter rather than directly accessing the variable, that should be a little slower, right? Because I actually have to go to the method, and the method has to go and grab the thing and return it. And that makes perfect sense, but it's not true. If you do a test, and I've done these tests, it's just as fast. Why is it just as fast? Because of the optimizing compiler. Under the hood, the compiler realizes you're doing something like that and actually skips all those extra steps and goes directly to, or that's what I assume it's doing. But when I've done tests on this, but by calling the getter billions of times and doing the timing and then accessing it directly billions of times, the same amount of time, it's exactly the same. Sometimes it's faster when you do it this way, sometimes it's faster when you do it the other way, but only by a very, very small amount. Which says the lesson is that actually your code, believe it or not, is not a very good model for what gets executed, because they do all kinds of stuff to it. So a lot of the tricks that we used to use to try to squeeze some extra performance out of our programs actually can be counterproductive. Okay, so now let's come back to this. Now notice I've defined John to be a person, but instantiated him as an employee. Absolutely legal. So the question is, which toString is it going to call? Is it going to call the one for person, because I've declared to be the type to be a person, or is it going to call the one for employee, because that's the type that it actually is? And the thing is that it could be either. I mean, it's not a law of nature. It's just something that they decided, and you could make a case for both of them. And so like whenever you have a question about what happens if I do this, or what's it going to do, write a little test and see. That's really the only arbiter. Okay, so what it's going to call, as I said, what it does is it looks, regardless of what variable type it is, it looks for the actual no kidding object type, which in this case is employee. It's going to do that one. So here's John. He has no salary, and there's today's date. So if we want to give, now let's give him a salary. So let's give him okay, now I gave him more decimals than now. Okay, here's another static method where I can just simply give it the year, the month, and the day of the month. So let's say that John was hired in 2015 in February 13th. Okay, so now this is one of the many methods where I can say, okay, here's a date, and it's going to be this date, no kidding. And now, okay, so now, again, notice that even though I gave it many decimal places, it rounded it, and it rounded it down to the 2. And if I want to make that look a little more pretty, I can actually, kind of a little more like that. I can put a little $sign in there.
Does it truncate it, or does it round it down?
That's a good question. Here's how can we find out? Well, let's. I believe it rounds. It rounds, I believe. Yeah. So here I gave it 23.55, and it rounded it up to 24. So, and it's not. Again, it's not absolutely clear what it's going to do. I mean, there's no way I could know beforehand unless you happen to know what it is. It's not like you can kind of reason it out. Is it going to truncate, or is it going to round? It's whatever they decided to do. in this case. And the thing is that this is only for display purposes. The value underneath is still the closest that a digital computer can come to representing this floating point value. Notice I didn't say it was that value. It was the closest that a digital computer can come to representing a floating point value, because a digital computer cannot accurately represent any floating point. Well, maybe a few it can, but most floating point values cannot be absolutely accurately represented. Okay, so there's another one of the cool things you can do is this. So let's make that look like a getter. Now there's a helper class called chrono unit, and it has a little nice method between. Okay, so what this is going, what a chrono unit has, in fact, now you I know they're red squigglies, we'll fix them in a second. Okay, what is that thing? That's a class. We don't know what package it's in yet. Do we? Yes, we do. It's in the java.time.temporal package. Okay. Now, what type of thing is days? Okay, there are only 4 possibilities. It can be an instance method, it can be a class method, it can be an instance variable, or it can be a class variable.
It's a static variable in the class.
Exactly. It has to be a static class variable because we use the name of a class dot days. Now, is this going to be a primitive or an object reference? Days.
Object.
It has
using like a method on this.
Exactly. Yeah. So because we're invoking a method on it, and now what type of method is this going to be? Between is going to be an instance method, because days is a static variable, but it's an object reference, and we're taking an object reference and invoking a method on it, and so that means that it's an instance method. And what does it do? It says these are how many days are going to be between, in this case, now and when I hire. And actually, that's going to be backwards. So I actually want to put the early one first, as it turns out. So I want to put the hire date. Oops. Okay. So this is going to be the number of days between this date and now. So this is how many days this guy has been hired. Now, but it's still complaining. And what is it complaining about? It says incompatible types possible lossy conversion from long to int. Okay, so what does that tell you? Okay, so I returned an int, but this is giving me a long. And I can find that out by kind of going to the source. See, okay, so between, and it's giving me a long. So it wants a long, but I'm saying take this long and stuff it into an int. So, longs and ints, they both represent integer quantities. It's just that longs can represent much bigger ones. Now we're talking about the number of days since someone was hired. So is that going to overflow ints, or do we really need a long? Now, why does between use longs? Because their units are actually this kind of goes back to Unix days. What it uses as its method of computation are the number of seconds since January 1st, 1970. And that's a kind of a bigger number than number of days that somebody's been hired. Bless you. Okay, so I have two. When you're okay, I'm confronted with this. I want an int, maybe, and it's giving me a long. So I have two choices. I can either change this to a long. That would be one possibility. Or I can coerce this into an int. Now, I mean, because it's not a floating point, I don't have to worry about rounding type of stuff. The only thing I have to worry about is that if I have a long value which is bigger than what an int can take, and I just kind of coerce it into an int, it could be a big negative number. But in this case, in this context, the number of days, is not going to overflow an int. So, and again, there's no law of nature on this, but I can, in this case, I can always take an int and put it into a long, because an int will always fit into a long. A long will not always fit into an int. But in this case, I am 99% sure, 99.99% sure that the number of days between when you were hired and today is not going to overflow an int. So I am absolutely confident that even though you've given me a long value, I can always put it into an int. And therefore, this Java will accept the cast, but what it does is going to be on you. Okay, so now instead of, well, let's add this. Let's add that to this. So, all right. So now, okay, so here's John, here's his salary. Here is, he was hired back then, and it's been 1,810 days. Now, remember I said what makes it complicated is if I want to figure out how many days are going to be between two arbitrary dates, in this case, it has gone over the leap year of 2016, and then the non-leap year of 2000, and and then today is 2020, so there was just that one leap year. If I, let's see, if we make it, let's make it 2005, then we're going to go over a bunch of them, and now it's going to be this many days. But remember, it has to figure out, okay, what's a leap year, what's not a leap year. It counts the extra day, etc. It counts the extra day for the leap years, doesn't count it for the non-leap years, including the divide by 100 ones, etc. Okay, so local date does that. Okay, so now we want to, I want to do this other piece here. So let's, I have time to look at the manager, and for the manager, they've added this sort of bonus thing. Why? Because managers are special. Okay, so how do we do that? We are going to create another class. And it's going to extend employee. And notice that as soon as we've done this, we start getting complaints. Now, you remember why we start, why is it complaining? We can kind of, it says no suitable constructor found for employee, no arguments. So they haven't written anything and already it's complaining. So this is pretty annoying. And it is, but it's less annoying if you understand why it's doing that. Do you remember why it's doing that? So why is it complaining? It says no suitable constructor found for employee, no arguments. What the heck is it talking about?
you have to import?
No, I mean, when I'm in the same package as employee, so I don't have to import. But that's a good, you know, a lot of red squigglies are from import, so that's a good place, but that's not it, so I'm sorry.
Does the employee constructor have, arguments?
No, it's not importing. Okay, remember what is it that every class has to have? A constructor. If you don't define a constructor, what does it do? It puts one in with no arguments. Okay, well, which is not a problem in and of itself. But then for every constructor, what is the first executable statement? It's either a call to this, if there are more than one constructor, or if there's only one constructor, it has to be a call to super. And if you don't put it in, Java puts it in for you. So, it's complaining because I have not defined a constructor, so it gives me a zero argument constructor. Again, that in itself is not a problem. But then it put that constructor in and says, oh, you haven't called super, so I'm going to put that in for you now. And now it's calling super to the employee class, but the employee class has two constructors, one that requires a string, and the one requires a string, a double, and a local date. And it's saying, hey, they're not there. Okay, so the thing about the red squigglies is you want to get rid of them as soon as possible, so that when you're going forward, anything you do, if you get a red squiggly, it's because of something you've just done. Okay, and just sometimes the messages you're getting are a little confusing. So it's important to understand this thing about constructors, because it's very common. If you have constructors that have arguments, as soon as you define your class, it's going to start complaining. So the first thing you should do is at least write one constructor that calls the super. Okay, so that's just to get rid of the red squigglies. I'm not finished on this. But when you're writing stuff and you see the error, then get rid of the error as soon as possible. Otherwise, if I were to let that continue and I just start writing code and then it's not working, why wasn't it working? Was it not working because of the original thing, or was it because of what I just did? Now, if I get another red squiggly complaint, then I know it's because of something I just did, not because of something I did a little while ago. Okay, so that's it for today.